Hello, beautiful people. Miss Beeching here. In this skill, we're going to learn about the basics of counting methods or combinatorics. We're going to look at permutations. This is a method of counting large combinations or possibilities. For example, if you wanted to know how many possible Tats Lotto winning things there are, you would use combinatorics. We're going to look at the one called permutations. So, for example, when you are unlocking your locker, if you are going through the different possibilities on your lock, there are many possible permutations. So when we calculate a permutation, which is also known as an arrangement, it's just a way of working out the number of possibilities, but there's going to be lots of possibilities. There are two types we usually deal with in combinatorics as permutations and combinations. And the main difference is where order matters or where order doesn't matter. So you can see on the left here, there's different combinations with the numbers 1, 2, and 3. And it counts as 6 different outcomes here where the order matters. But when the order doesn't matter, all of these count as one outcome because they've got the numbers 1, 2, and 3. Doesn't matter what order they are. So this is a permutation, which is what we're going to look at today. And this is a combination which is a little bit more complicated to calculate. So it'll probably be something you do next year or in VCE. To help us out with calculating permutations, we're going to be using a lot of factorials, which I always find really fun because it's signified with an exclamation mark. So say, for example, I wrote this. It's pronounced as 6 factorial, and all it means is 6 multiplied by the numbers that are lower than it, essentially. So 6 times 5 times 4 times 3 times 2 times 1. And you just count downwards and multiply all the numbers. To calculate something like this, it's really handy to kind of group the numbers in sort of logical ways and multiply them out instead of going 6 times 5 and then times 4 and then times 3 and then times 2. So here I would group 6 times 5 into 30. I would group 4 times 3 into 12, and I group 2 times 1 into 2, and then work that out. And so I get 720. I would actually go 12 times 2 to get 24 and then multiply it by 30, but that's just the way I work it out. You can also do it on your calculator as well for bigger numbers. You just need to put that exclamation mark in. Find the button that has the exclamation mark. All right, so let's actually have a go at calculating a permutation. And the situation we're going to discuss first is a 3-digit PIN code. So that's like a code you put in to access, bank accounts or money, something like that. And I want to know how many possible PIN codes there are if I can only use the numbers 1, 2, or 3. And the reason we're limiting it now is so that we can visualize all of the outcomes first before we start doing calculations for bigger numbers. So we could list all the possible options, and here's one I've prepared earlier. These are all the different possible outcomes with 3-digit PIN codes with the numbers 1, 2, and 3. There's 27 in total. This is a pretty small one. If you tried to list every single outcome for larger ones, you would be here until the end of your life. You would be writing down permutations forever. So we're going to look at some more efficient ways to calculate these. And let's apply it to this PIN number thing. And I like to think about numbers of possibilities. So if I draw boxes to represent each of the 3 digits in the PIN, okay, and it could make any of these, I like to think about, all right, if I'm filling the first number, how many options do I have? I've got 3 options. I could put the numbers 1, 2, or 3 in. Okay, and then I've actually got the same thing happening in the next box because there's nothing that says I can't repeat numbers. So I could also say, okay, this one has 3 options and this one has 3 options. All 3 of them have 3 possibilities. So to work out the total number of outcomes then, I would say, okay, 3 options times 3 options times 3 options. And that's going to give me 3 cubed, or 27 total outcomes, which is what we got when we listed all the possibilities, but it's a lot quicker this way. Okay, now let's do a different situation. this time we're going to be taking 3 friends and putting them in a line. And we're going to put Bob, Alex, and Van. You can have any 3 people. And I'm going to call Bob B. I'm going to call Alex A. And I'm going to call Van V. So these are the 3 friends. And we're going to try and work out the number of ways we can arrange these 3 people in a line. And so let's draw our boxes. In the first one, we've got 3 options. Okay. Now in this second one, we only have 2 options, because if I've already put Bob here, I can't put Bob here again. I've already used up Bob, if you want to put it that way. So here, I've only got 2 options left. And then in the last one, we've already used up 2 of the people, so there's only 1 person left to pick from. So I've got 3 options, then 2 options, then 1 option. And you can kind of visualize it in a tree diagram like the one in the skill page, like this. We've got 3 options, and then it splits into 2, and then each option has 1 after that. But obviously you don't want to draw a tree diagram every single time you do this. So generally, we just apply this kind of approach where we think about the option at each step. And again, just like before, we can multiply. So we can say, okay, 3 options times 2 options times 1 option. And notice how we've got a factorial happening here. Okay. So we've got 6 total options of putting Bob, Alex, and Van in a straight line. And this thing where a factorial pops up happens in a lot of different situations. So if you're ever taking a set of things and just arranging them in a line, you're going to end up with that factorial to work out the total number of outcomes. So let's try that out for a bigger number. Let's say we're putting 7 people in a line. And we want to know how many different ways we could rearrange those people within that line. So I'm going to draw these boxes one more time, and then after that I'm not going to draw them, because hopefully you'll get the idea and you don't have to draw boxes every single time. 1, 2, 3, 4, 5, 6, 7. Okay, so these are the 7 places we could have the people. And in the first one, we've got 7 options of people to pick from. And then we've used up one of the people, can't use them again. So now we have 6 options. And then we've used up 1 option. So we have 5 options the next time. We've used up 1, now we have 4. Used up 1, now we have 3, 2, and 1. By the time you get to the end, you've used every single person except for the last unlucky person to get picked. So there's only 1 option left. So our total options, just like before but with a bigger number, would be 7 times 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 7 factorial. Woohoo! And that one I would put into a calculator because lazy. It's 5,040. So there's 5,040 different ways to arrange 7 people in a line. That's a lot. You get really big numbers with this really quick. Factorials make very big numbers. All right, so that's arranging people in a line if we use every single person. Sometimes, though, you're going to get situations where you have a bigger group of people to pick from or a bigger group of things to pick from, and you only pick some of them. So let's say there's 8 people, and let's say it's for school council. So there's nominees, and we need to pick 3. So we're not going to put all 8 in. And we're going to say that the order matters here. So we're going to say that the first person gets president. And the second person gets vice president. And then the third person is just a council member. So we're selecting from 8 and we're picking only 3. So let's draw our boxes again, but this time it's going to be a little bit different because we have, in this first box, we have 8 options. In the second box, we have 7 options, and in the third position, we have 6 options. So you'll notice that the total number of outcomes this time is not going to be 8 factorial because we're not filling the rest of those boxes. We're only picking 3 people out of 8. So our permutations, or our number of options, would just be 8 times 7 times 6. And there wouldn't be the other numbers because we're only picking the first 3. So that would give us 336 possible school councils if we pick 3 out of 8. And that's it for this skill. If you have any questions, ask your teacher. This area of maths is quite complicated, so don't be afraid to ask if you get stuck. Good luck, and see you next time.